Thanks for coming to my presentation. My name is Guseva, and I'm a software engineer in Yandex. My team develops and maintains a mobile development infrastructure. Today, I want to share with you my experience of merge health solution in monorepository. First of all, I want you to have a small understanding of my company and why exactly we use a monorepository. I work at Yandex and I live in a country that has the biggest amount of Yandex services on market, but even I don't know all companies' projects because Yandex really does a lot. We have a voice assistant, maps, taxi, food delivery, and many, many more, even self-driving cars and a search system on the top of this. To develop all this stuff, Yandex has more than 12,000 employees in 30 offices, and most of them are somehow related to software development. For all these projects, Yandex has its own code hosting called Arcadia. I'm pretty sure that it's somehow related to Yandex founder name Arkady. So it's an old service, and a lot of projects have been living there from the beginning, but not all of them. Yandex also have been using enterprise GitHub, GitLab, and bitbucket for every mobile project and some other projects. One day we made a decision to move all together to monorepository in Arcadia. A bit later I'll explain why. So infrastructure was ready enough for backend projects, and we just moved them one by one. And for front-end project, we decided to move them to GitHub monorepository first, and then to Arcadia as one big project. The same thing we decided to do with mobile project, but for historical reasons, we chose bitbucket as a temporary monorepo storage. So my team's responsibility was to move mobile projects. Just a couple of numbers about Yandex monorepository. For now, we have almost 2 million files, 6 million commits, 2 terabytes of data. Of course, it's size with whole history. It's not only trunk, it's all release and feature branches, and 3,000 commits to trunk per workday. You can see an asterisk above the word statistics, so it was Arcadia without any mobile and some other projects. We did some tests and understood that neither enterprise GitHub nor GitLab or bitbucket can survive under such load. That's why we chose Arcadia. We have a fuse-based VCS for it. With this logarithmic scale, I want to show you in comparison that Yandex monorepo is a pretty big one. So in this picture, you can see that GitHub average size of repository is just 1 megabyte. 90% of GitHub repositories are less than 100 megabytes. For instance, Linux kernel repository size is less than 10 gigabytes, and Chromium is around 16. Google source code repository is 90 terabytes, so Yandex monorepository looks pretty big one. Now I want to remind you a small theoretical part about repositories and give you a short explanation why we chose monorepository. There are 2 types of architecture for source code management. Polyrepo means using a separate repository per project, and monorepo means that we're using one repository for everything. All applications, frameworks, services, libraries are stored together just in one place. A couple of words about pros and cons of monorepo approach. Every project of repository has a ready-to-use infrastructure, common infrastructure. So code check, code review, code navigation, build, deploy, and monitoring systems, everything is already prepared. So every developer can easily understand how to work in any other projects in company, and in case of a new project, he does not need to think about a lot of things. Sometimes we may need a neighbor team to apply some changes in their project. And when they don't have time this week, month, year, they say that they will do it in Q5, we can just easily do it ourselves instead of begging and waiting. Sometimes we also need to do changes in several projects and at the same time. And with monorepository, it's easy to do because it allows to do changes via atomic commits in several places. Also, code reuse is getting more convenient with common code because everything is in one repository. One more advantage of monorepository is that it's more convenient to do a global refactoring because you can change everything in just one commit. Not so important advantage, but it's nice to have some standards in development process, so no exotic languages and libraries is a good thing. So, as I said, common infrastructure is one of advantages of monorepository, but someone has to develop it first and then maintains. So, of course, it costs some resources. For instance, I'm one of these resources. And generally, we have more than 60 people only for mobile infrastructure, and most of them are developers as me. It's possible that a required library is not in a repository, but it's open source. So we need some resources to add in it and then for updating. Sometimes it can be easy and fast, but sometimes not. It depends on library and language. It's also important to work on code health. It includes fighting with unnecessary dependencies and dead code. It's not so visible in pullRequestId, but it's pretty annoying in monorepository. The most useful branching model for a big monorepository is a trunk-based development model. All dev teams share the main branch called trunk or master. For every feature, they create a short-lived feature branches, and they can merge them to trunk only after passing required pull request after build automations. Every release is branched from trunk, and it's also forbidden to commit there directly. Because of big amounts of developers and changes to trunk, without some restrictions, trunk would not be stable. So one more thing that we want to see in our monorepository is a green trunk. It means that not checked updates can be merged in trunk, and trunk is always valid. It helps us to make continuous delivery a reality, and we can reach it by pre-commit checks. The only way to have a constant green trunk and fair green trunk is to simulate state of target branch after merge commit, merge of pull request, and test all updates on it. Fortunately, in bitbucket, they have these branches by default. It's called merge branches, but generally it's not so difficult to create it ourselves. So how does it look like? Let's say we have a new branch created from trunk, and we updated some code, did some changes, and opened a pull request. So automatically bitbucket calculate a merge branch and this branch is showing how the resultant merge commit will look like. If the target branch was updated before merge of the pull request, merge branch is recalculated again. So you have a new version of it. The same thing happens when a development branch was updated. So now introduction is over, and we came directly to my presentation topic problem. As I said, the main goal of my team was to move a lot of mobile projects to monorepository. To do this, we temporarily used bitbucket to merge all projects to single repository. During this work, we faced merge hell. What is it? For each pull request, bitbucket generates a merge branch. And to ensure green trunk, we have to run all related builds on this branch. So after merging this pull request, we can be sure that trunk is still valid. Let's say we have n pull requests, all of them ready to merge. It means that we already ran all builds on it. And all of them are from independent projects. Let's say first one was merged. So now we have to run again all builds related to n-1 pull requests. The same thing happened when we merged second pull request. So with this, we have a quadratically growing amount of rebuildings for pull requests, even if they were independent. For instance, if we have two projects, mail and maps, and mail was merged. So we have to restart everything for maps. And in normal size repository, it's not a big problem, but in monorepository, it's a big one. As we started to solve this problem in mobile monorepository, I want to show you some numbers related to it. There are about 30 different services. It has approximately 300 open pull requests in every moment of time, and we merge like 50 pull requests per workday. Roughly speaking, we merge pull requests every 10 minutes, and we have to rerun all builds from 300 open pull requests. Here is an average build duration for top 5 build configuration according to statistic for usual week. You can see that average build duration is like 14 minutes, and also some builds are waiting in a queue, so it should be something like 20 minutes. Also, average pull request has more than one build, so it's something like one for test, one for code coverage, and average number of builds is about 3. So if we compare average build duration and average interval between rebuildings related to pull request merges, it becomes clear that pretty often we have a situation when we need to restart a build when previous one was not finished. So based on these numbers, if we just move all projects to monorepository without solving this merge hole first, developers would revolt. So when we had a task to move all projects in monorepository, we started to think how to solve this merge hell. For historical reasons, mobile services use TeamCity as a CI service, but not only. That's why we had to find a solution that can work with several CI tools. So there were our options. First one is just to run all related to pull request builds only when development branch was updated. For instance, let's say we created a branch, did some changes, created a pull request, run all tests on it, all builds, and then trunk was updated. So we don't do anything. We don't run any build. And then if we commit it again in our branch, we need to restart our build, and we need to restart it on updated merge branch. But with speed of our trunk updating, here it's a big possibility of invalid trunk with this solution, so we rejected it. Second one was a merge pin. Merge pin is a custom merge branch that is not updated during a set amount of commits in target branch. So it's always updated based on changes in development branch, but it waits and commits in target branch. So let's say if and it's just two. If we created a branch, did some changes, then created pull request in trunk and run all builds. If target branch was updated once, we don't do anything. If it's updated second time, we don't do anything again. But if it's updated third time, we need to restart our builds. But we decided that it's also not enough for us, because if we don't run on every updating, it's still not a green trunk. So for increasing speed of merging pull request, we optimized a merge queue by developing a CI plugin based on independency graph. How it looks like. Firstly, we catch an event from bitbucket by pull request event listener or merge check. Pull request event listener observe events related to pull request changings like opening, reopening, deleting, declining, merging, updating of trunk if someone merged another pull request, and updating in development branch. So merge check is started when someone updates a pull request page. Bitbucket merge checks allows us to recommend or require specific conditions on merge. Then, if it's pull request event listener, we start a conveyor. And if it's merge check, we check if we already have results for builds for pull request related to pull request in our cache. And if we don't have, if we have, we just send it to bitbucket. And if we don't have, we start the conveyor and send a pending mode for pull request to bitbucket. What exactly the conveyor does? The conveyor gets from pull request merge branch config list. It's a list of all configs related to projects in our monorepository. Then it gets a changing list. It's a list of all changings that we did in pull request. Then it filters necessary builds based on these diffs and configs. The main idea, The main idea of plugin is reduce startings of builds on not related to project changes. So if we then conveyor for all changes, check if we already have it in cache. If we don't have it, also check it on TeamCity. Then if we don't have it in TeamCity, we start a new build. And if we have new changes related to our pull request project, we start TeamCity build also. And by built-in plugin, commit status publisher, we have all needed information about this build. As I said, the commit status publisher sends all information related builds. It works every time when status of build was updated. So when build was put it in a queue, when it was started, finished, cancelled, or stopped. So we have all information about build status, state, and number of it. Every team can set their settings to our plugin in config. We have two types of configs. First one is a root config. We use it to fast traversal of other configs, and it just has paths. And also we have project configs. It's a second type of config. We use it for starting builds and for understanding how to filter it. So it has a name, it's just metadata, because actually project can have more than one config. So also it has a list of CI builds. It can be TeamCity build or any other CI tool which we use. Then it has some required parameters like ID on TeamCity and optional parameters, so we don't need to prevent merge if optional build is failed. And also it has some information for filtering. It has included passes and included branches. Let's say some teams has very heavy builds and they want to run it only on release branches. And also it has excluded target branches and excluded passes. So let's say if they don't want to run builds on documentation updatings. How exactly it works? Let's say that we have two projects, both independent of each other. So first one is mail, and we run mail build on any change except changes in documentation files and only in mail directory, but only if target branch is trunk. And also we have maps project, and it has maps built on any change in maps directly for any target branch. So for instance, if we create a new branch from trunk and make some changes in mail main Java file and then create a pull request to trunk, we have to run mail build. Then if we also made some changes in two README files in maps and in mail, we don't need to restart mail build because we excluded MD files from it in config, and we need to run maps build. Then if we have new updates in target branch in something like command directory, we don't need to rerun any of our builds because it's not dependent change. But then if we had update on something related to mail, we need to restart mail build, and we don't restart maps build. We just get old status of it. We also added a couple features for convenience of our developers. First one is skip checks. It's pretty useful when developer made a super hot check, super hot fix, and he doesn't want to wait when builds were successfully run, because it's more important to merge it as soon as possible. Or maybe he just changed MD file or comment, so he doesn't want to wait. But all we know that developers can be lazy and self-confident, so for preventing hiding of just skipping checks and merging pull request, we added with this comment from developer name. Also, we added rerun of builds from bitbucket from pull request page. So now I want to show you performance of our plugin. This is a 3 days interval statistics of builds mergings. If you can see dates, don't be surprised. We don't work on holidays, we just have Christmas in January. So green color represents merge commit updates. Its number of merge branch rebuildings, the same number of times was conveyor actually started from pull request event listener. Orange color represent affected builds. It's number of builds that we would start without our plugin. So blue color represents started builds, what was really started from us. For instance, on the peak point, we have almost 200 of affected builds, and we started only 6 of them. If to get numbers of affected builds and started builds in this 3 days interval, we can see that we started more than 4 times less builds than were really affected. In real numbers, it's more than 3,000 builds, only in 3 days. Let's call to mind the table that I showed in the beginning. As I said, an average build duration is about 20 minutes. So we saved more than 40 days of server time just in 3 days. But it's always time for improvement, but it's always space for improvements and optimizations. So for pull request, we also use aftermerge plugin in Yandex. Developers can mark their pull request as ready to merge, then a scheduled job from this aftermerge plugin will go through all pull requests, and if checks are succeed, it will merge them. So we decided that we can make a parallel mode of this merging. With this optimization, we can save time of recalculating merge branch and comparing diffs and running all checks for ready pull requests after upstreaming update. So, for instance, let's say that we have 3 projects and 5 pull requests in it. Like first pull request has changing in project 2, second pull request has changing in project 1, and so on. With sequential mode, if we just merge first pull request, we have to recalculate merge branch for all other 4 pull requests and run checks and maybe run builds. So with parallel mode, we can just go through all these pull requests and mark independent projects. So let's say that we do it. Firstly, we mark project 2 as independent because it's the first one. Then we go to second pull request and mark project 1. Then we go to third pull request and mark project 3. And for fourth pull request, we can't do it because project 1 is already used. The same with fifth pull request. So with this parallel mode, we can merge first 3 pull requests, and we need to recalculate merge branch and run all checks only on 2 others. And at next time, we can merge fourth and fifth pull requests together because they also don't have dependent projects. So in conclusion, I want to remind you some main points of my presentation. First of all, green trunk is possible, and it's possible even in monorepository, even in a big one. Secondly, an infrastructure investment is always paid off and eventually make developers happy. In my case, developers were scared to move to monorepository, and I can understand them, but we made it smoothly for them, so now they really like it. And the last one, generally there are a lot of existing tools for everything, so if it's possible, of course, it's better to use an existing tool instead of creating something new and maybe not so good. But sometimes we can't get all what we want from existing tools, and we don't have to stay with something not convenient. Sometimes it makes sense to spend time on developing a new tool. Thank you for your attention. If you have any question, I would be happy to open up the discussion, and also there is my contact information, work email and Telegram account in case you have it later.
Thank you very much, Maria. Great. So any questions for Maria? Yes. I'm going to bring you the microphone. We have some time for questions, so.
Hello, thank you for the talk. Very nice. I'm Nicolas Fournet from the University of Geneva, and I have a question about how you do to, when you have to start multiple build, let's say a developer change something in a common library, a shared library, how do you know which other projects are affected and which one you have to rebuild? Is it something you have, it's hard written somewhere in a config file, or
Yes.
is it automatic?
We write it, so if you have a project, let's say you have maps and you are dependent on common library, like, I don't know, something dependent to GPS, anything. So you just write it here. So you write not only your build, you also write, and actually you can be dependent not on project, you can be dependent on a specific class.
But how do you know which one you have to rebuild, which project you have to rebuild? Because you know you have, let's say, a project A, B, and C.
Okay, so you mean in here if you have several numbers of projects in this config. So every project have included target branches, excluded paths for every project. They are different.
Okay. Okay, thank you.
Other questions for Maria? Yes.
So Joe Milic from Geneva State. I'd like to know if it's more or less transparent for the developer, or is there a steep learning curve to do this?
Yeah, it wasn't easy to make them to move on this plugin, if you mean this.
Yes.
Yeah, we had a lot of talks, we had some meetings, we explained them why they should use it, because generally when we tried to move to monorepository, of course, a lot of developers were against of it because they understood that we can have this problem. But then we came to them, we said that we fixed it, and they believed us.
So anyone can use the system immediately without having any directives or special...
We have a good documentation for it.
Yeah, there's a protocol. There's a protocol to follow if you want to...
Yes.
Okay.
If I understood question. Yes. Yeah.
Ça va, c'est bon pour la réponse? On a encore du temps, donc si vous voulez approfondir un peu le monorepo. Sinon, j'attends encore quelques instants, voir. Sinon, on va dire que ça va être bientôt du coup le lunchtime. Parce qu'on va avoir un peu de... Ah non, you have some examples.
Okay, with monorepo, how do you fix the issue? Because the repository is huge, so every developer who wants to start working with this repo must clone, and this pulls a huge amount of data. So how do you tackle such a problem?
Again, please.
This,
I understood huge data.
This monorepo is huge.
Yeah.
So every developer who wants to work with this monorepo has to clone the entire repository, and it is huge. It will take a lot of time. So how do you fix this?
What takes a lot of time?
A clone, and maybe also...
Clone. We don't clone. We have a fuse-based VCS. So we don't clone all of it.
Can you explain this more? I don't get it.
Okay, so we don't use Git or Sven. We use Arc. It's an internal VCS system, and it's based on Fuse. So it gets only projects what you need, and then depends on graph, it gets some more dependencies. So in one time you have not so much data. It's just several gigabytes. Of course, with this number of data, you can survive with a normal laptop, and it's a lot of time.
Okay.
So you cannot develop with your laptop, or
I can what?
you can still use your laptop to
Yes, yes.
work thanks to our system.
Yes, exactly. The only one problem is that, for example, if you don't have internet connection and you need something what you didn't download before, yeah, you need to survive without it.
Hey, thanks for the talk. I have a question not strictly related to the topic of your presentation, but if it's a monorepo, I guess you have dedicated teams to develop features in like sub-projects. For example, in case of Google, you have dedicated teams that work only on parts of the big monorepo, and they only review the code in their monorepos. They have some kind of a access control list so that they can only access sub-projects in a monorepo. I'm kind of curious, how do you manage who can see what? Like what developers can see, what they cannot see, if you actually have some kind of restrictions on the monorepo or not, or you just let your developers work, like have access to everything, or...
Okay, for now we don't have it. Because in monorepository now we have only internal projects without any outsourcers, and generally we don't have outsourcers, so it's okay to show all code to everyone. But yes, we have several projects. For example, algorithm of search system, it's of course closed, but it's not in monorepository now, and yes, it's closed.
Okay, so how do you solve problems, for example, with code reviewing in such a big monorepo? How do you, like, do you have people responsible for some parts of the code?
Yes, for every project, when you move to monorepo, your project, you just fill something like a special config with all people who should be invited to code review. Also, you can add yourself in any code review. And you can also manage how many approvals and from who you need to have. So it's just like in Bitbucket or any other project.
We still have some time. Yeah, and we still have some questions.
Second questions. Still related to the shared library. When you make a modification in this one, and like all your projects have to change something into them, who's responsible to make all the changes? Is it each team working on each project, or there's someone who make the change in every project?
It depends. If it's something like in case of updating contrib version, let's say from, I don't know, not between JUnit and G4 and JUnit 5, because you need to change everything, but in something small, you can just do it yourself if you need, and then people will see changes in their project, and they just need to approve it. But if it's something which makes other teams to also change them, and you just need to provide them information first and then change. So you need to make them agree with your changes.
Okay, thank you.
Yeah, there's one there.
Hello. I understand that from the perspective of operations, you have to optimize because CPU time is expensive, etc., etc. But did you try to put some responsibility on the developer side? Sometimes, I don't know, forcing to squash commits before pushing, or avoiding builds just for simple modifications? Because it's a matter of balance. I mean, I can as a developer, I can trigger many builds just because I'm renaming variables or classes, but there's no meaning in running all the tests just for that.
I don't think so, because if you make changes, for example, in your project, generally you will start only builds from pull requests who dependent to this project. So I don't understand how you...
On feature branches, for example, I can keep pushing code just with small changes and trigger builds when I can, for example, squash before sending. Have you ever tried to force some good behavior on the developer side before...
Okay, got you. Yes, we do it, but generally main idea of chunk-based development is that you have short-lived branches. So you generally have a branch for feature for like 1-2 days. That's all. Of course, they don't just merge pull request with one line every hour of workday. Of course, they don't do it.
No strict rules.
No, we don't have straight rules.
Any more questions? We have Maria here. She can answer a lot of interesting things about monorepo and trunk-based development. No? You've got all your questions out? Well, then I'm going to thank very much Maria for being here.